as I mentioned before, when we're sketching cubics, we're only really interested in the x and the y intercepts. If we can determine those locations, we can get a pretty good sketch of the graph. Now, when a cubic is in factored form like this, we can use the same kind of techniques that we used on quadratics to find the intercepts. And as always, the x-intercepts are going to happen when y is equal to 0. So we're going to take this equation, we are going to replace the y with 0 and solve. Now, the nice thing about factored form is we have three factors multiplied together, three things multiplied together to give 0. Now, if things are multiplied to give 0, we must conclude that at least one of those things must be 0. So either we have x minus 1 equal to 0. Now, for that to be 0, x would have to be 1. Or we could have x minus 2 equal to 0. For that to happen, x would be equal to 2. Or we could have x plus 1 equal to 0, in which case x would be minus 1. So in order to have x-intercepts, one of these conditions must be true. They're the three situations where the equation can equal 0. So these are, in fact, our three x-intercepts, these 3 points. Now, to get the y-intercept, there's a number of ways I can do it. I could expand this and get the constant term. I could notice that the constant term will come just from the three constants in the bracket, so minus 1 times minus 2 times 1. It's one way of doing it. Or alternatively, if we're not sure, we can make this x equal to 0 and substitute that in. So y equals 0 minus 1, 0 minus 2, 0 plus 1, minus 1 times minus 2 times 1, as before, equal to 2. So this is going to be our y-intercept. Now, we need to get a neat smooth curve through these 4 points. It looks a bit odd because there's kind of 3 sitting down here and 1 up here. Something we need to know about cubics. Cubics can have an extra turn in them. So a parabola or a quadratic was shaped like one of these with a single turning point. A cubic could be shaped like this, or like, if I go the other way, like this. So they can have these up to 2 turning points. There is a third type which kind of looks like it does a bit of a wiggle. We'll come across one of those later on. However, most of the ones we'll deal with will have 2 turns in them. So to get it to pass through all these points, we're going to have a couple of turning points. This one is an upwards facing one. The only way we can get these points to join in a cubic way is if it goes something like this. Okay. Now it is tempting to put these turning points halfway between each set of intercepts. That's actually not going to be the case. Okay, it doesn't necessarily have the same symmetry as a parabola does, and it's actually quite difficult to find those turning points, and we won't worry about that until next semester.